A very good morning, all. We have seen in the previous lecture that how we can convert a regular expression into a finite automata. We will continue with the practice of converting a regular expression into a finite automata. And today we'll be solving much more typical questions. And believe me, after seeing this video of solving these 2-3 examples, you'll be able to solve majority of the questions of conversion from regular expression to finite automata. So let's start with the very first question, which is shown on the screen: a star b, then in concatenation with a plus b asterisk. So to start with, we all know that we make a state and there would be an next state definitely. In the starting state we are getting a star, so we can write it down directly with our practice now that a star is this. Because this is very simple, we can write it down directly that a star we are getting, and on the first state we get a star, and a star means it is a loop. Wherever it is an asterisk, it is a loop. Then after a star we get a symbol b. So for getting a symbol b, we have to transit from one state to another state. So we make a transition from one state to the another state. And on reaching to this state, the input which is coming is again an asterisk. So we put asterisk means a loop. And after this asterisk, there is no other state. So this is the final state. And on this loop, what is written? A plus b. So a plus b means that a or b, which can be directly written as a comma b. Now we can give name to these states: q0, q1. Now let's check it again: a star b, a plus b whole star. So this can be solved directly. We can get the answer. In gate, this thing becomes very important, that how fast we are able to solve. In case of your examinations, if we are doing a BTech examination, then we do it in certain steps. For example, we make a state, then we write down the whole expression over here, that it is a star b, then a plus b star, and this is another state. Then we solve this state by state, that this state is a star b, then we move to another state, then again we say that it is a plus b star, and we can solve it by making different states. Just for the exam purpose, we can solve it by making different states, but we can, at last we will go to this answer, that is the direct answer. So this is how we can convert a regular expression into a finite automata directly. Now let's see onto another question. Now this question is trying to confuse us by putting the same AB. On one there is a complete asterisk, and on second one there is only asterisk on B, and everything is on concatenation. So concatenation means it has to be repeated. So in the first very state we are getting an input which is on asterisk. So asterisk means loop. So we put a loop, and for the time being we write AB. Completely we write AB over here. We will break it down afterwards. To avoid the confusion, we write complete AB. After this AB, we know what we are getting. We are getting an A. तो A आने पर एक स्टेट से दूसरे स्टेट पर ट्रांजिशन होना है, तो एक नई स्टेट बना देते हैं, है ना. On reaching to this state A, what is the last state? It is B asterisk. B asterisk means it is a loop. So we make a loop, and the loop is of B, and this is the last input. So this becomes the final state also. But we know that this thing is not allowed in the transition diagram. In the final state automata, there cannot be a single loop which having two inputs together in a concatenation. So we have to break this thing. So let's break this thing. How to break this thing? The loop was having A, B. So first input was A. On getting A, move to another state. On getting B, move back to this state. So this is AB asterisk, and the remaining automata remains the same. The remaining automata remains the same. Now we can give name to these states: Q0, Q1, Q2, and this is the final automata. We can check it again. A, B asterisk, A, and then B asterisk. So this is the final automata. Let's start with the uh, third expression. Now don't be confused that this is dot of two things. So let's first solve with the first thing. We start with the initial state. In the initial state, the first thing which is ever whatever is there is on a loop. So we make a loop and we write the complete expression without worrying that this is thing has to come on a loop. Then it is a concatenation of BA. So first a B comes, then A comes, and we reach to the final state. Very simple. This is the initial state. Now this is the thing which has to be solved. Rest all the things have been solved. So A plus BA. This plus means this is a parallel path. So let's remove this plus from here. And how can we remove this plus from here? This is one loop. Let this loop be for A. We make another loop for BA. And the rest of the automata remains the same. We will give name to the states afterwards so that first we reach to the diagram. So this is how we have simplified it. Now again this BA is not allowed over here. We have to break it into the states and concatenating the states. So let's break it down also. So the first loop is of A, the second loop is of BA, where first B comes, then A comes. So first B comes, then A comes. Then we can say it is B, then A, and we reach to the final state. So this is how the complete automata has been made. Now we can give the names to the states now: Q0, Q1, Q2, Q3. So see, it appears that it was very difficult, A plus B asterisk. So how will we make A plus B asterisk? We easily solve this thing by putting it on a loop, writing it down alongside with the loop, then breaking the plus into two different loops, and then concatenating it. So we don't have to rush to the answer. Sometimes we have to break it into the states like we have broken down, and sometimes we can directly put the answer. It all depends upon the situation, how the question is. And we are not concentrating on the minimum number of states, we are concentrating on how we can solve, how the expression can be converted into the automata. First task is this, you know, minimization we can do afterwards. If the question is there that what are the minimum number of states which are possible, then we can think of the minimum number of states. So let's see one more example which is also a very good example. Double A plus triple A whole asterisk. It appears to be very simple that there is only a single state because it is an asterisk. So we say okay, it is a single state, and this state should also be the final state because it is an asterisk. And on this state we are having then expression double A plus triple A. This is the simple thing we can do, that this is an asterisk, therefore we are repeating double A plus triple A. Then we can break this thing, we break the loop, we break the plus, double A, triple A, and this is the initial state also. Now this double A is also not allowed and triple A is also not allowed on a single loop. So what to do? So we again break double A. How to break double A? By getting two states in between. This is how double A can be broken down. For triple A we will put one more state. So, and now we give the numbers Q0, Q1, Q2, Q3. So that appears to be little abnormal type of automata, but this is the solution for this double A plus triple A. Though it is having a large number of states, and frankly speaking these many states are not required. So how to reduce the states, this is another part. There are different methods to reduce the states. We can follow the complete method for minimization, but if we have to reach to the answer early, then little tricks have to be applied, little mind have to be applied. So we'll try to reduce it by using little tricks also. But first, let us make it in a much better way so that it appears good, though the appearance does not matter at all. So this is with AAA, we can give it Q0, Q1, Q2, Q3, and these two were A's. This was a single state which was the initial state also, and AA and AAA have been participated. Now let's see what is this language tells about, means how to minimize it. What is this language telling about? This language asterisk means epsilon is accepted. Is single A accepted in this? No. So single A is not accepted. Double A accepted? Yes. 3 times A accepted? Yes. 4A accepted? Yes. If this 2A will come 2 times, then 4A will be accepted. 5A accepted? Yes. 3A's comes and then 2A comes. So 5A is also accepted. 6A is also accepted. Similarly, 7 times A is also accepted, and so on. So this language is accepting epsilon, or it is accepting a to the power n, where n is greater than equal to 2. N is greater than equal to 2. A2, A3, A4, A5, anything is accepted, but single A is not accepted. So how to go to this? So the language is such that single A is not accepted, but all other things is accepted, and epsilon is also accepted, but single A is not accepted. So epsilon is accepted, it gives us a thing that initial state is the final state, because epsilon is accepted, one thing. But single A is not accepted. If single A comes into the picture, then we move to a state which is not a final state, because on getting a single A, we have to move to another state which is not a final state. But after getting a single A, if another A comes, this another A is accepted, and on reaching crossing this two A's, on crossing this two A's, any number of A's can come. After this 2A, 3A comes, 4A comes, 5A comes, any number of A's can come, but the restriction is 2 A's should come in between. So 2 A's are coming in between. After that only the string is accepted, or nothing is coming. So we are making the initial state as the final state. So this thing can be reduced, the same expression can be reduced to this expression just by little bit of practice and little bit of thinking that what are the minimum number of states if someone asks. So minimum number of states would be 3 states in this case. So this is how we can solve the numericals for conversion of a regular expression into a finite automata. Thank you.